All right, so let's talk a little bit more about the different types of data and then get into some examples and see how you are at recognizing what types of data that we're dealing with. And the reason why this is important is it helps us kind of figure out what summaries that we can and need to calculate for, numerical summaries that we can calculate for, if we know what type of data it is. It also will help us figure out what kind of graphical display is going to be the best way to display our data to help us in our making conclusions and drawing inferences and whatnot. Okay, so remember our different types of data: nominal, ordinal, interval, and ratio. And so the first thing to understand is, and really and truly, about the only thing we need to kind of keep track of is that nominal and ordinal are going to be the two types that, generally speaking, are going to be our qualitative, or if you want to, categorical variables. They're the ones that we're going to pretty much place all of our subjects into a category: color or gender or what else? Ethnicity, ethnic race, whatever. Okay? Interval and ratio are going to be more of our quantitative, where we can assign a value to the items, and the items have a value that makes sense in terms of calculating averages for, or things like that, right? So if we know that, if we at least know the difference between qualitative and quantitative, then we're going to know what kind of numerical summaries we can come up with and how to display those different types of data. Okay? So again, just a quick reminder, nominal data is that very basic level of data. It's every data piece that we get will fall into nominal. And so we don't worry about ordering anything with nominal. Things like color, gender. Red's not better than blue. Blue's not better than yellow. Male's not better than female. Whatever. There's not an order to those types of data pieces. And that's going to be your nominal. And so obviously, if you're putting, well, we'll come back to that in a second. Ordinal, you are going to order things, right? Your Likert scales are the best example of that, where you're still going to place pieces of data in a category, but they're going to be ordered. Strongly agree, neutral, disagree, strongly disagree, right? Strongly agree. Those are all in a very specific order. Very satisfied, satisfied, neutral, unsatisfied, very unsatisfied. Obviously, very satisfied would be better than satisfied, right? So there's an order to it. It still may not have numerical meaning. And the spacing between them might not be the same. So even if you're going to get away from non-numerical data, things like rate this on a scale of 1 to 5, right? Well, the difference between 4 and 5 for me might be smaller than the difference between 4 and 5 for you, if you're going to rate a particular product or whatever. So it's too hard to maintain a distance between the different categories there. And again, these are going to be sort of your qualitative. Qualitative data, again, we're going to create bar graphs and pie charts to help display that. There's not going to be a lot of numerical summaries that are going to make sense with qualitative. Okay, and then you've got interval and ratio. And so remember, the interval data has numerical meaning. It has an order, and has even spacing. But one item in this set of data doesn't make sense to talk about being twice as big or half as much as another. So that's what we mean by not multiplying or dividing. It doesn't make any sense. And then there's not a meaningful zero. And temperature is probably the best example of interval data, right? 96 degrees isn't necessarily twice as hot as 48 degrees, right? It doesn't really make a lot of sense to talk about it that way. Of course, 96 degrees is hotter than 48 degrees, but in terms of twice as hot, I don't think we really think about it that way. And then plus, we've already heard a couple of times that 0 degrees is not an absence of temperature, right? So it's not really a meaningful zero. So that's kind of what we get at there with interval. And then ratio data has a meaningful zero, makes sense for one item to be twice as much as another. Most of the data that we're going to want to concern ourselves with are going to be ratio data. Things like how much time it takes to drive to school, right? 20 minutes to school versus 10 minutes to school, right? 20 minutes to school is twice as long as 10 minutes. Number of text messages. I may have gotten 75 text messages today, where you may have gotten 250 text messages today. Or, my daughter may have gotten 0 text messages. So it means that there's an absence of text messages. Then that makes sense, right? And so, again, these two are going to be your quantitative variables. These are the guys that okay, I can't spell. These are the guys that we're going to want to calculate numerical summaries for: average, mean and median, standard deviation, things like that. And then our graphical displays are going to be things like stem and leaf plots, dot plots, scatter plots, things like that. So there's a difference between those guys. Now, are we comfortable enough to be able to take something and place it? And so if we're going to survey 50 students regarding their eye color, our choices here might be blue, green, brown, or gray, right? What kind of data is that? Okay. Is it nominal? Sure. There's not an order. Blue eyes are not better than green eyes, and so on and so forth. There's not an order to it. They're definitely in categories. Okay, ordinal, well, since we've already said there's not really an order to it, then it can't be ordinal. And your interval and ratio data are the ones that we tend to want to calculate averages for in some numerical summaries. So that's pretty much it. This data set would be nominal. So we'll do some bar graphs and pie charts, frequency distributions and things like that. So blue eye color may show up 20% of the time in our data set. Green eye color may show up 15% of the time. Brown eye color may show up, 65% of the time. So we can put numbers to it, but it still it doesn't make sense to have an average eye color, right? So our qualitative versus quantitative. Okay. What about if we survey 50 students and we ask them how long in minutes they take to get ready for school? Right? It's layered. It's kind of weird to think about this being layered, in that it does fit the nominal description, not in the way I just talked about it, but all data is nominal. So if you're going to come across a question like that, then all data is nominal. There is an order to the number of minutes, right? 10 minutes is more than 5 minutes, things like that. Interval, it does fit interval. There is equal spacing in the minutes, right? The difference between 1 and 2 minutes is the same as the difference between 3 and 4 minutes. So it's equal spacing between our item points. And then it does also fit ratio, because there is a meaningful zero. Like if it takes you 0 minutes to get ready for school, then that's an absence of time, right? It takes no time. 20 minutes is twice as long as 10 minutes, just like I was talking about before. So the best level for this data set is ratio. Okay, and now that we know that we're going to calculate numerical summaries. Mean, median, mode makes sense, standard deviation. And our graphical displays would be like dot plots and scatter plots and things like that, and we'll get to those. Okay. In that same survey, if you ask how much do you like statistics on a scale of 1 to 5, where 1 represents hate and 5 represents love, where would that fit? Well, again, in the terms of definitions, every data set's nominal. Ordinal, right? Is there an order to it? Well, 5 is better than 1, I guess, if you want to think about loving, of course, being better than hating, of course. So there is an order to it. Again, what would make someone go from a 4 to a 5 might take more for that person than someone else. So the distance between those two is not the same. So it does kind of fit ordinal. Since that distance is not the same, it's not going to really make sense to say that the difference between hating it and only slightly hating it, 1 to 2, is the same as what would take you from a 4 to a 5, right? So it's not going to fit interval, and it definitely doesn't make sense to take the average of this, although we do it, right? I mean, we do it in terms of if I were to take everybody's rankings and then try to average those reviews, right? Amazon does it all the time. This product gets 4.2 stars out of 5, which you got to be really careful with. It doesn't really hold a lot of meaning. Because what makes someone say 4 is going to be drastically different than what makes someone else say 5. And getting them from a 4 to a 5 could be very different as well. So anyway, I think this guy is going to stop at ordinal, which means that we can create some proportions for it, right? 30% of the population rates this class a 2, where 60% of the population ranks this class a 4. So we can do proportions, percentage of people that rank 1, 2, 3, 4, or 5. That might be the only numerical calculation that makes sense on these guys. Okay, and then bar charts and pie charts are going to be frequency distributions are going to be what we'd want to talk about with this data. Survey 50 students, what temperature should the classroom be to produce optimal learning? Well, we're going to start with nominal. Right, every data set's nominal. And then ordinal, there is a ranking to the temperature, right? One's higher than another. Interval, there is even spacing. The difference between 1 degree and 2 degree is the same as the difference between 4 degree and 5 degree, and so on and so forth. So that fits. But again, with temperature, 0 doesn't mean no temperature at all. And 75 degrees is not twice as much as 27.5 degrees. So this guy's going to stop at interval. Okay. And last one here, the uniform numbers of CGHS football team. I want you to take a second and think about that. Well, where would you land this data set? Of course, it's nominal. So every data set starts at being nominal. Definitely going to place everything in a category. And then doesn't make sense to rank these numbers in an order, right? Is number 20 on a jersey really better than a number 10? Is it arbitrary? Can jersey number 10 be standing, anywhere in relation to number 20? It's kind of weird to think about, but the answer to that is no. I mean, the order doesn't matter on a jersey number. 20 is 20. The number 20 definitely is bigger than the number 10, but in a jersey number, it doesn't mean anything better, right? It's just a different number. So this data set would actually stop at nominal, even though it is numbers. Okay, so hopefully a little bit better idea of what it is that we're talking about. So again, nominal, ordinal, interval, ratio. I think really by the end of this, as long as you understand at least a little bit about the difference in these guys, but specifically that these first two tend to be what are going to be your qualitative variables, where we're going to do bar graphs pie charts and calculate proportions. That's what we're going to use these mostly for. And still good data. I mean, we can still get good data out of them. It's just what we're going to use them for has got to be we got to be a little bit careful about. And then these guys are going to be your interval and ratio data is going to be your quantitative stuff, where we'll calculate mean, mode, median, standard deviation, and then our graphical displays might be stem and leaf plots, histograms, or dot plots, things like that. Okay? So if you kind of get that, then you're doing really well. Okay?